Hey everyone, this is update number 2 for Team Wars. Will, Antonio, Robbie, and Sears. That's what it stands for. Pretty cool, huh? All right, so kind of reiterate, our goal was to try to hack my car, my 2020 Hyundai Sonata. And so one of the things we're looking at is the Android application that's used to unlock the car with NFC and Bluetooth. We tried a few different techniques to analyze that. We used Mob SF for dynamic analysis and static analysis. We also showed in the previous update that we were looking at using Ghidra for static analysis of the libraries. The app relied heavily on compiled libraries, those SO files, and those had hundreds of thousands of functions. We spent a lot more time trying to go through those functions, but just decided it was very difficult to find a meaningful entry point or meaningful function.
So we also explored the avenue for the infotainment unit to see if we could gain access via the engineering mode by uploading malicious APKs or accessing other system processes. Within this, we were able to enable Wi-Fi and actually sniff some of the traffic communications, but the only thing we could find were just normal pings from using ICMP packets. There wasn't any open ports within network scans, leading to a lot of other roadblocks. It was also, we were unable to find any sort of Android settings for uploading APKs as well, which is really our thought of the main avenue of attack through the engineering mode, but it seemed not to be possible on this car model. Next slide. So as I said, we couldn't upload any APKs, but we could upload a file image to the car directly for the different firmware versions. It was running. We found that it was running on an open source version of Red Hat that was specially designed for Mobis, which is the infotainment system. However, we weren't comfortable uploading the file system, which seemed to be the best avenue of attack with modified firmware to cause any sort of vulnerabilities, as this could easily damage the car, and we're not sure if we could revert it back. So this has been the stopping point for the project, as we determined that it was too risky, but also too time consuming with it in the timeline of the rest of the semester as well. So therefore, we're going to start going to our backup plan. For our backup plan, we'll be doing a system security review of the Wyze camera system and be comparing the current firmware version for the Wyze Cam 3 to the Wyze Cam 2 previous version that has some known security flaws. So we could be conducting network analysis as well as some system analysis on the cam system, and with the end goal being a fully unauthorized access to the camera remotely via whatever means we can find possible, and then eventual write-up comparing the improvements from the previous firmware version to the current one.
So far, we have conducted a preliminary analysis on the differences between Wyze version 2 and version 3. Using Binwalk, we're able to extract all embedded files and executable code from the firmware for both second and third generation devices. Both use SquashFS compression, which is a compression library mainly used for Linux-based embedded devices, and we found that each have similar file structures. After uncompressing the folder using the unsquashfs tool, we can freely peruse the directory, and navigating to the etc folder brings us to the shadow file. We ran John the Ripper on both versions to recover the password. Version 2's root password was encrypted using DES and was cracked in 2 minutes, but version 3's was encrypted using SHA-512. Other security researchers have posted the default root passwords for version 3 online, but using them in a word list in conjunction with John the Ripper has proved fruitless. When navigating to the init.d folder, we saw a bash file named RCS. For version 2, we can see that it starts the telnet daemon as a background process, while the version 3 firmware does not. At first glance, this led us to believe that telnet was not enabled in version 3, however the telnet binary was found in the bin directory for both versions. As these devices are primarily cameras, the iCamera binary caught our attention. By using grep and the strings tool, as well as Ghidra, we found functions that seem to start and stop telnet after connecting to a network, which leaves the possibility open for an insecure remote access to the device.
So with our revised schedule now, going to our backup plan, we proposed that going into the next week that we focus on sniffing communications and finish the analysis of the previous firmware version 2, and also start on a more thorough analysis of the firmware version 3. There's a companion app as well within Wyze, and we can begin the static analysis phase of the application. By the following week, we're hoping to get into the dynamic analysis phase of the application and actually work on modifying the firmware if necessary, or exploiting the actual firmware things that we found from the previous week. The third week, we'll start compiling the findings for the report and start to review analysis steps to repeat if needed, At this point, we'll start compiling whatever we have, even if it is documenting the security improvements and with us ending that we're not able to compromise the system. This will be in preparation for the final week where we'll begin our presentations and the paper and board for the project.